Understand about some functions. I'm not going to tell you the theoretical part of what is function or what are the what are the uses of function, but I'm going to directly tell you the different types of function and how to pass the parameters into it. So we have functions and we can pass the parameters to function. Why functions? Because we want to make our program simple. Okay, so the basic syntax of writing a function is return type, name of function, then parameters, and this is the body. So this is the basic prototype of a function. Okay, so now let's say I have void sum and I have written a integer b, and I can write directly return a plus b. This is the simple basic function. Here if I have written void, then I cannot return the value. So this is a return type mismatch, because of which I have to change my return type into int, because I am returning the sum of two integers which will generate an integer again. So we have to write the integer type of return type of integer. Okay, otherwise it will throw an error. Now if I don't return anything, I just calculate something, then I can write void, which is completely fine. Now if I change the value of a and b here, then it will not change the value inside my calling function. Why? Because these values are being copied, which I will explain you when I will show you the activation function. But here I am showing you there are basically two ways where we can pass the values. So call by value, and the second one is call by reference or call by address. So if you pass the value by using call by value, then after returning to calling function, values will not change, whereas in call by reference values will change. So a classic example to show this is a function of swapping. So let's say if I write integer main and I have written x is equal to 10, y is equal to 20, and I write swap x comma y, and if I write here cout x y, let's say return 0, and my swap function is like this: integer, let's say a, integer b, integer temp is let's say temp, and temp is having a is having b, and b is having temp. So here if I try to print cout a and b, then what will happen? And if here I will write cout a and b. So see this, inside main I'm just giving you a glimpse of activation record here. So when you make a function, when you are in the main function, what will happen? Inside main, this x will be created having memory and value 10, y is created having value 20, and when you call this swap function, the value of x and y will be copied inside a and b. This swap will be made inside our stack. Now it will become active, and the values are created, variables are created: a having value of x which is 10, and b is created having value of b which is 20. This value y will be copied in b. Now when you come inside this temp is created having no value, and when you try to print this, the value of a is 10 and value of b is 20, so it will print 10 20. When you assign a value of a into temp. So obviously here we have temp equal to 10 because the value of a is 10. Then a equal to b, so the value of b will be into a, that it will become 20, and later on b will become 10 because the value of temp is 10. And then a is 20, so it will print 20, and b is 10. And when you go back inside the main function after completing the swap function, the value of x and y is still 10 and 20. So this is 10 and this is 20, which is the original values. So these are not swapped because of this very reason, because you have made the copies and this is called by value. But then if you pass the address of x and address of y, and you have created the function like this, void swap integer asterisk a integer asterisk b, and you write here integer, let's say temp, and you write cout asterisk a asterisk b, temp is equal to asterisk a is equal to asterisk b, and actually asterisk b is equal to temp. So what will happen, let's see that also. Now if we create a memory, inside this memory we have main function. In this main function, when you go inside this main, x is created having value 10, and let's say the address is 2d, and y is created having value 20 and value, let's say address is 3d. So when you make a swap function, the address of x, which is 2d, is copied inside a swap function of a pointer. So swap, and here a is made a pointer. This is a pointer, this is not a normal variable. You have asterisk available here, so 2d is available here, and then b is a pointer. So this arrow before the a or b is showing the pointer. This is my convention, not the standard convention. And b is having the address 3d, which is address of y. And now when you make a temporary variable, this is a variable and having no value right now, when you print asterisk a and asterisk b, what it means is, asterisk means dereferencing. So go to this address a, go to this value a and dereference it, means go to the value at a. So this address 2d, go to this address and get the value. This is the dereferencing. So it will print 10, and this will say go to 3d, go to 3d and get the value, which is 20. So now 20 is changed. Now when you write temp is equal to asterisk a, so temp is equal to asterisk a, what was asterisk a? 10. Asterisk a is equal to asterisk b, so asterisk a is nothing but 2d, so this will become asterisk b, this will become 20. Then asterisk b, which is this, asterisk b was this, so it will become temp, which is 10. So now if you print here cout asterisk a asterisk b, so asterisk a is nothing but the value at address 2d, which is 20, and asterisk b is nothing but the value at address 3d, which is 10. So it was 1020 before, now become 2010. And when you go back to the calling function, the value of x and y is also changed. The value of x is 20 and the value of y is 10. So that's how the call by address will swap the values inside the calling function also. Because when you are calling by value, you are copying the value, whereas when you are calling by address, you are copying the address, not the values. So the changes are made inside the original copy. So understand this by a layman language. For example, You have made a Xerox copy of notes of your friend. After making the Xerox, if you are trying to make changes in your Xerox copy, it will not make the changes in your friend's original notes. Okay, it will not make the changes in your friend's original notes. That is call by value. But what if you have borrowed the notes? Now you are trying to change inside the notes only, and then you are making the Xerox. Okay, so this is like a call by address. When you make a change in the in the original copy only, then obviously in the Xerox copy will changes will already made. Okay, so you can understand like this. This is call by value and call by address, and inside the parameters, inside this function parameters, you can have combination of anything. So you can have integer, you can have float, you can have integer asterisk, you can have something something. So it is not required that all should be pointers, or all should be integer, or all should be something else. You can have any different types of parameters. Okay, one more thing, how to pass the 1D array. I'm not talking about 2D array today, but how to pass the 1D array inside the function. So if you have int main, and inside the main you have written ARR of 10, and after that you are doing some taking values from the user inside this array, and you have called a function sum. So if you pass ARR, so ARR is the base address. Okay, so you can write like this. So void sum. Since this ARR is the base address of the array, so you have to write ARR, which is of integer type, with these square brackets, so that we can understand this is an array. This is also right. Also, if we write asterisk ARR, this is also right. Both are right. Okay, why both are right? Because this is an address. This is an address. Why? Because let's say this is my array. Base address is, let's say, 2000, which is pointed by ARR. I am trying to pass the 2000. So it can be a pointer, or it can be ARR with brackets. Both are right. But I prefer this and not this. Reason being, because it may get confused that by writing asterisk ARR, that this is just a plain pointer to a single variable. But then if you write with square brackets, then it is obvious that it is an array. Okay, so you can pass ARR, and then you can catch it by using ARR and square brackets. This is how you can pass the array inside the function, and whatever you do inside the function, it will make the changes in this original array, because you are making changes inside this by using this address only, and you are not passing the copy of that array. Okay, also sometimes what students do, they also do like this, array of address of array. This is wrong. Why? This is address of address. Okay, this is not address of array, this is address of the first address. This is wrong. Sometimes students also do like this, which is equal to this only. They both are equal. Either you write ARR, or you write address of first element, which is same. So no problem in both things. But here you can just write ARR, and after, along with, you have to write brackets and address of, so it is little larger, whereas this is smaller syntax. So this is preferred. This is how you can pass the 1D array inside the function. Okay, I believe this is clear.